Hello everyone, this is Mr. Couple. In this video, I'm going to be walking you through the freefall motion practice question that you see on the screen right now. In this question, an object is thrown vertically upward with an initial velocity of 20 meters per second. And it's thrown from the edge of a cliff that's 30 meters above the sea. And so the first thing we need to realize in looking at this question is that the sea is our reference point. And so that's going to be the zero height right there. So we're going to make that be our zero position. So that means that the ball is actually starting with a height of 30. That'll be important down here when we try to find what the maximum height is. So before we do that, what we want to realize is what's actually happening here is that this ball is going to go flying up into the air and it's going to reach some maximum height here. So I'll just put that there and I'll grab a text box and I'll say that, okay, up here, this will be the maximum height. Let's make this small, like 12. So it's going to reach the max height up here. And then that is going to be the first part of the motion. Because what's going to happen to the ball after it reaches this highest point? Well, it's going to fall back down. So this is the first part of the motion. And then we'll realize that then from the max height, it's going to fall back down and splash into the sea. And that'll be the second part of the motion. And what we recognize is that there are actually two motions that are taking place here. There's this upward displacement, rest, then a downward displacement as gravity pulls it back down to the ground. And so we're going to set up this problem as two separate problems. The first part is rising up to the highest point, and the second part is falling down from the highest point. To help us, I've created two Suvat tables. First Suvat table is here, and we'll do that for the first part of the motion, this first displacement. And we'll use the second Suvat table for the second part of the motion. It's very important that you realize that all the quantities in the Suvat table are for the same displacement. You don't want to accidentally mix up numbers from the other part with the first part. You want to keep them separate from each other. So now we're going to start plugging in numbers into our table. So let's go. So we don't know what the displacement is because that's what it's asking us to find. We do know what the initial velocity is. It was given to us. The initial velocity is 20 meters per second. It did not tell us what the final velocity was. And it also didn't tell us what the acceleration is. And it definitely doesn't mention the time. So you might think we're stuck. But we actually know more than what we think we do here because we know that the object is in free fall. It's been projected upwards. So that tells us that the acceleration is the acceleration of gravity. So that was actually hidden. There was nowhere where it actually told us that that was the acceleration. We just know that when an object is flying through the air, that's its acceleration. We also know that if we're going to the maximum height, we know what the final velocity is. When an object reaches its maximum height, the velocity is 0. So even though it never said that anywhere, we know that from logical thinking. So it must reach a final velocity of 0 at the highest point. And then we can see that those are the three quantities that we know, and the other two are the quantities that we don't know. So we don't know the displacement, and we don't know the time. But when we read this question, the question is asking us for the height, which is the displacement. And so this is the quantity that we're trying to find, which means the other quantity is the one that we don't care about. This will now allow us to figure out which equation to use because we need to use the equation that doesn't care about the time. And the equation that doesn't care about the time is the one that's missing the time. And that's that equation. You can see that the other equations all have time in them. And so we're not going to use those equations because they have time in it and we don't have time in our question. So this must be the equation that we need to use. So we'll write it out. V squared equals U squared plus 2AS. And now we just need to plug in and we can find the displacement. But it's important to realize that this actually isn't going to answer the question. We'll figure out what this displacement is, but we won't actually know the maximum height because this is the displacement starting from 30 meters. To find the maximum height, we're going to actually need to go all the way back down to the sea. But we'll worry about that when we get there. For now, we're going to solve the displacement, which means we're going to have to move the u squared to the other side and divide by 2a. We'll do this in 2 separate steps. First, we'll get rid of the plus u squared by subtracting it to the other side. Next, we will find the displacement by dividing both sides by 2a. So s will be equal to v squared minus u squared divided by 2a. All of these quantities should be known to us. So let's double check and make sure they are. I'm going to line up these equations first, just so I can save some space. There we go. So let's check to make sure we know all these quantities. Do we know what v is? Yes. Do we know what u is? Yes. Do we know what a is? Yes. Those are the quantities that we need, and those are the quantities that we have. So we can plug them in. The final velocity is 0. The initial velocity is 20, divided by 2 times the acceleration, which is negative 9.81. So let's grab our calculator. We'll throw our numbers in here. We're going to open up parentheses. It's going to be 0 minus 20 squared. We're going to take that whole quantity and we're going to subtract by the quantity of 2 times negative 9.81. And then that's our answer. I'm going to take a screenshot of my calculator and paste it into the Cami file so I have a record of what calculations I performed. And that way I can go into the equation over here and write out my answer, 20.39. And that's going to be meters. But remember what I said earlier, this actually isn't the answer to the question. We have found the displacement from the 30-meter starting point. What we found was how high this was. That we know this distance between these 2 points, that distance is 20.39. To find the height, we have to actually go all the way back down to the 0. To do that, we'll call it h. We just have to take the 20.39 and we have to add on to it that 30 that it started from. And so this will give us our height of 50.39, which we can round off and say to 2 significant figures, it's approximately 50 meters. And that's how we'll report the maximum height of this object, is we'll say that it's 50 meters above the water. For the next question, it's asking us for the time that it takes to reach this maximum height, which means it's still part of the same displacement. It's the same motion that we already drew here for this first part of the motion. So we can use the same Suvat table. We don't need to make a new one. We can use the same table. In fact, what you'll notice is this time we do care about the time. So let's use the equation that has time in it, but's missing the other quantity. The one that's missing s is this first one here. So let me box that equation. This is the one that we need to use because all the other equations have s in it and we don't want to use the s. You might be wondering, wait, Mr. Couple, we do know the s. We found it up here. And to that, I would say, you're right. You're totally right. But are you sure that we got this right? Are we sure we got the correct answer here? I don't know if I trust myself. You know what? It would be better to do the question assuming I got this wrong and not even using it down here. And that's what I'm going to do, is I'm going to do this calculation without using this answer from up here. But you totally could if you wanted to. You could use that answer and any of the other equations. But I'm going to assume that I don't know this and solve it as if I didn't care about it. V equals U plus AT. I usually like writing in red, so I'll switch it over to red. Okay, let's start thinking about the numbers. So V is going to be 0. Okay, cool. So we're trying to find the time. Okay, here we go. We need to find the time. So that means getting rid of the U to the other side and dividing by A. We'll do it in 2 steps. So we'll have AT is V minus U. So we subtracted the U to the other side. And now to find the time, we have to divide by the acceleration. So T is going to equal V minus U divided by A. Let's go ahead and select the annotations and line it up and make it look pretty. There we go. And here's where we'll start to plug in our numbers. We're going to have a final speed of 0, an initial speed of 20, acceleration of negative 9.8. We can pull up our calculator one more time and punch these numbers in. Open parentheses, 0 minus 20, that's the top of my fraction, divided by negative 9.8. When we get this time, once again, I'm going to grab a screenshot of my calculator and paste it into the Cami file as a record of my calculations. Let's write out this number, 2.04. What I'm doing here is I'm just writing an extra sig fig. I know that I only have 2 sig figs in this question, so now I'm going to round it to 2 sig figs. But I want to have that extra precision just as a record in case we need to use this number again later on. So that way we can avoid rounding errors. Because if we use 2 later on in the question, we might introduce some rounding errors. And so we want to carry that extra decimal just to avoid those extra rounding errors. This is indeed the answer for the time it takes to reach its maximum height. It's 2 seconds. So now we fully understand this first displacement. And so just to emphasize that, what I'm going to do now is go back here and replace these question marks. I'm going to replace them with the actual values that we just calculated. So the displacement was 20.39 meters. And the time that it took was 2.0 seconds. Let's put the 2.04 just to carry that extra precision. And so now we know everything there is to know about this first interval of the motion. We know all the values of all the Suvat quantities. This is going to be really useful later on in the problem, because now we want to find the time it takes for the rock to hit the sea, which means we need 2 times. We need the time it takes for it to go to its maximum height, and then the time it takes for it to fall back down. Well, we already know the time it took to get to the maximum height. So now we just need to figure out how much time it takes to fall back down to hit the sea. So we're going to look at the second interval of the motion, which is what we've already got set up here. We know that for the second interval of motion, the displacement is negative of the height. So the displacement's going to be negative 50.39. We also know the initial speed. When you're at the highest point, that's where we're starting from. We're starting from the maximum height. So the initial speed is 0. Okay, and we do not know the speed that it hits the water at. That is not a known quantity. It's not told to us. It's going to fall and it's going to splash in the ocean. We have no idea what that speed's going to be when it splashes. So we're going to leave that as a question mark. We do, however, know the acceleration. In fact, it's always negative 9.81. So I'll just copy that annotation down here. But we don't know the time. So that's going to be our unknown as well. And this is how we set up our Suvat table for the second part of the motion. For this part 2, is we know the displacement is negative 50.39. We know that the starting speed is 0 and the acceleration is that of gravity. But what we don't know is how fast it's going to splash into the water at, and we don't know how much time it's going to take. Well, it's asking us for the time, which means that we don't care about the speed that it splashes into the ocean at. That's the quantity we don't care about. So we can figure out what equation to use, because we want to use the equation that's missing the v. So it's not this equation. This is the one here. We're going to cross out the equations that have v's in them because it won't be that equation. So it ends up being this equation that we need to use. So we'll go ahead and type out this equation. S equals ut plus 1/2 at squared. Now, when we look at our Suvat table, we actually realize that u is 0, which means that this u right here is actually going to go away. So I'll go ahead and rewrite this equation without the u there, because the u is going to go to 0. So this term, I can draw an arrow through it to say that it goes to 0, which means that this term goes away and it's gone. And now we're trying to find the time. So we got to do a little bit of algebra here to solve this for the time. The first thing we'll do is we'll multiply the 2 to the other side. And while we're at it, we might as well divide by the 8. So we're going to get that t squared is 2s divided by a. Next, we need to take the square root of both sides of this equation, and we'll have that t, the time, is equal to the square root of 2s over a. Let's line up our annotations, make them look nice. And now we'll plug in the numbers that we have. First, we have the displacement, which is negative 50.39. And we have the acceleration, which is negative 9.81. Let's go grab our calculator and throw these numbers into the calculator. We'll do the square root first. Square root of, we'll open a parenthesis for the top, 2 times negative 50.39. Close the parenthesis for the top. Divide by the bottom, negative 9.81. We'll evaluate this and we get 3.205. We're going to quote this time as 3.21 with that extra sig fig. We can see that that 5 ends up rounding up that 0 to be a 1. And this is a seconds. But now here's the thing. This isn't the answer to the question. What we just found was we found the time that it took for this thing to fall from the maximum height. We did not find the time it took to hit the C, because this time, 3.21 seconds, this didn't include the initial part or the first part of the motion. So to find the total time from launch, when you launch it up, and then it comes back down, we need to add together both of these times, which means we need to take this 2.04 and we need to take this 3.2 and we need to add these two times together. And so I'll do that here in blue. And I'll say that the total time t is going to be 2.04 plus 3.21. And this is why we wanted to carry those extra digits of precision, was because now we'll avoid rounding errors by carrying those extra digits of precision. Let's make a little note to ourselves here that we're finding the total time. So we'll just go grab our calculator again. All right, we're going to need to add together these times. Well, I've already got the one time in my calculator already. And so I'm just going to add to that the previous time, which was 2.04. And if we add those up, we get this result, 5.2451. And so we'll quote that on our paper as saying that t is approximately equal to, and I know that I'm done now. I'm not going to need to use this time again. So I'm actually finished. So I can just straight up write this answer down, round it off correctly. So that's going to be 5.2 seconds. And so that's our total time. And that's our answer to this question. The last question says, find the speed with which it hits the C, meaning that this quantity that we were missing for part C is now the quantity we want to find. And we can now use any equation we want because we know everything except for the thing we're looking for. We could use whatever equation has a V in it. So let's look at the equations. In my opinion, the easiest equation is the first one. There's no squareds. There's no any of that other crazy stuff like divisions or anything. It's just straight up this. So I think this is going to be the easiest equation for us to use to find the speed. But realize you could use any of the equations. The only one you can't use is this one because it doesn't even have the speed in it at all. But you could use either of these, and I think this is the easiest one to use. And so I'm just going to go ahead and use this equation. V equals U plus AT. Well, it's already solved for V. So all I have to do is just plug in the starting speed, which, well, the starting speed was 0, plus the acceleration, which is negative 9.81, and the time was 3.21 seconds that it spent falling. We're not going to use the 5.2 because that was the total time of the whole journey. We just want to know from this rest point up here, and it falls, what speed does it hit at down here? So that's just using the second time, which is 3.21 seconds. We'll pull up our calculator and we'll throw these numbers into the calculator. So we have 0 minus 9.81. Instead of doing plus a negative, I just did minus, times 3.21. And so we get this answer. I'll take a screenshot of it and paste it into my Cami file. And we'll go ahead and type out V and we'll approximate it to 2 sig figs. We'll say that it's 31. And you'll notice that I didn't put the negative, and there's a really good reason for that. It's not a mistake. I didn't put the negative because it's asking us for the speed. Speed can't be negative. And so this is the speed that it hits the water at. It's 31 meters per second. Well, that's it for this question, guys. So this is an example of a complicated problem where you have to break it into multiple parts, create 2 Suvat tables, one for each part of the motion, and combine it all together. And it's a really good example of how when you get the number out of the equation, oftentimes you're not done. You have to do a little bit of extra thinking to actually answer the question that you're being asked. The equations don't do the thinking for you. You have to do that yourself. Well, this has been Mr. Couple. Hope you guys have a wonderful day, and I'll see you in class.